All right. Well, thanks everybody for joining. Welcome to our first webinar. My name is Bill Brock. I'm the CEO of Peridio, and today we are doing a series on Beyond the Bench, scaling IoT teams that deliver ambitious products. Again, my name is Bill Brock, CEO of Peridio, and here with us today, our panelists are Astav Sacheti, who is a consultant and advisor from Tiger Firm, Mirza Shah, co-founder and CTO at Simbe, and my dear friend, Justin Schneck, co-founder and chief product officer at Peridio. And before we dive in, a little bit on Peridio, we are a software platform for distribution and management of modern connected devices, and we work with software teams at hardware companies who are focused on building robust and secure distributed products. One click deeper, what does that mean? We're a device-centric CI/CD, and we enable just-in-time provisioning, zero trust firmware delivery, very flexible management of embedded software and the related assets, and promote best practice collaboration workflows from development through test and release. Last and very important is that we do provide a device management layer, secure remote access, and a centralized source of truth for operations teams. All right, so Justin, who are you? What do you do? And let's get to it.
Great to dig in. My name is Justin Schneck. As Bill mentioned, I'm basic head of product here at Peridio. Previously, worked with a lot of engineering teams over the last decade and a half plus as both a co-creator of Nerves Project, which is the framework for building embedded devices with the Erlang virtual machine, and bringing that to fruition through product development for various different customers in different fields together at Very previously. We have a nimble team today, building a lot in engineering, design, and focusing a lot on the user experience and the developer experience in the platform. But overall, trying to be able to get all that together and ship great products.
And where do you spend your time? What is the part of the stack that you feel most strongly about?
I have a bit of a touch into a lot of different areas of interest, but my deep expertise is in the place where software meets hardware when it comes to embedded Linux, design, hacking, and platform integration. There's no bigger detriment to my time than when friends or colleagues would mail me boards and they would show up and I would just have to hack on them. So
The bring up guy.
a bring up guy.
All right. And next we have Shah from Simbe.
Hi, yeah, I'm Mirza Shah. I go by Shah, as Bill mentioned, CTO and co-founder at Simbe Robotics. At Simbe, we build autonomous mobile robots that do inventory in brick and mortar retail stores. We have robots that go up and down the aisles, take high resolution images of the shelves, upload that to the cloud. We crunch that data, and we're able to tell the retailer what's on their shelves, what's out of stock, what has the wrong price tag, what needs to be restocked, promotions that need to be put up, taken down, and much more. I've spent around the last 20 years in autonomous robotics, and am also an expert in the robot operating system, or ROS, which is sort of the de facto open source framework for building robotic applications.
Thank you very much. Really exciting to have you join us. Thank you. And last here, we have Astav. Astav, would you mind introducing yourself? Yeah.
Absolutely. So I'm Astav Sacheti. I am most recently doing some consulting work myself. So we formed a company called Tiger Fern, and we do technical and management consulting for anything from small to big companies as well. Before this, I have spent some time at Apple, Tesla, WeWork, and then most recently at ChargePoint. Similar to Justin, I started as a bring up guy, doing embedded software, and grew that team out and became led that team from an embedded standpoint. I've done iOS and macOS development as well. grown program management organizations, EE folks, technicians doing everything from mechanical to EE to software work in factories, been to manufacturing sites for both Apple, Tesla, ChargePoint a bunch of times. And yeah, so growing organizations being in that intersection of hardware, software, and manufacturing has been what I've been up to.
Thank you so much. All right, so for today, we've got a super cross-functional team, and some of these topics are back to basics, honestly. And so really excited to hear from Shah and Astav, and you think about these environments that these guys are operating in, and you can't always guarantee any sort of environment on the edge, whether that's a grocery store and you have people walking around. I know Astav has crazy experience dealing with all the different cars in different scenarios and deployments at ChargePoint. And so things in the physical space are not nearly as reliable or standardized as they are in purely digital software applications. So for today, we have 3 topic areas. First, we're going to start off with underestimating production, talking about getting products from the bench prototype to ready for manufacturing and some unexpected issues that could arise along the way. We're going to then pivot into doing things that don't scale and when is the right time to invest. A lot of us have startup experience, and paramount to the success of any startup is making the trade-offs that are right at the right time. And I think that with hardware development, there's a very different lens that you need to look at that through. Lastly, we'll close with a lightning round on building out cross-functional teams for hardware software development. And that should be a good webinar. We have about an hour today, so we're 10 minutes after right now. So each topic will be about 20 minutes, probably 10 to close out with lightning round. And if you have any questions, please do drop them into the Zoom Q&A. Daniel, also here, will be watching this and bringing them to the panel as they come in. All right, so let's get into it. So Justin, standard interview question here. Tell me about a time when you underestimated production and getting something from the bench ready for manufacturing.
Well, in a true interview question format, I should design this secretly as a pro, right? So production is never underestimated, and that's the first lie. So actually, I was considering this question for a moment, and while there's a couple different, there's a clever way to be able to look at this, and that production can be interpreted 2 different ways. In this case, I'd love to be able to get into some manufacturing, and the other way, it's underestimating your environment. And you know, just to kind of table set a little bit, when we talk about we here as a hardware device manufacturing products, you know, these products that get distributed to the field, there's really a stark difference between the kind of workflows that would go into developing and pushing things into a production environment for us than it would be for people who are designing software applications for the web. And primarily speaking, the web development has a nice sort of catch to always being able to unbrick production. There's always that sort of safety net that affords things like you know, just pushing things out to the actual greater web, because there's just so much more control over that environment, and where we don't really have that much control, or you know, we don't really have as much control over the principles of the physical world that these things are getting distributed into. So one way to interpret this really is you know, building a device that gets put into the hands of others, who then, when you look at them testing your device, and you're like, yeah, you press button A and then button B, and then they press like six different other things, or use it some other different way, or it gets put into a climate that's too hot. You know, setting the stage here in that case, I think one way that production is really sort of interpreted is this means for us of these harsh environments that really, when you have to consider those things, influences a lot of the work that you do on the bench. I mean, you have to be prepared for this. You have to test for these things. You have to kind of embrace these use cases a little bit more. And Subsequently, the flip side of this is going into a manufacturable product state. We've seen this many times in the past when designing and developing various hardware products where you have to actually go through a manufacturing procedure that the manufacturing line needs to be ready for these things. And so much about the assemblies, the cases, the designs, the mechanical, the hardware, the software, all of these disciplines coming together with their own nuanced limitations that become prevalent as you choose manufacturers and the equipment that they have and the lines that they have to design, that also can feed back into the progress that you make from the bench into production. People misunderstand the idea that when you create a hardware product or produce circuit boards, for example, that for every one you produce two, one of them to test the other at the end of the line. And so scaling up is really one of those feats that having gone through it with somebody who's an expert in that field can really save your product company a lot of time and effort, understanding the nuances that go into that end of line test. And even so much so down to the kind of software that you might need to run there. And as a small war story, before I'd love to be able to get some war stories in this case is from Shah and from Astav. One of which is something I always find striking that in order for you to be able to test your product, you usually want to be able to provide a manufacturer like a CM, contract manufacturer, suite of software that can actually test this stuff. And what they'll usually turn around and tell you the system that those tests are designed to be able to run on, which is usually some ancient Windows running PC that's wildly out of date and has very high limitations set onto it as well. And so coupling that with then the inability to really kind of replicate a lot of that old archaic environments that you're given access to, that tends to lead to a lot of back and forth and wastes, maybe not wastes, but requires a great deal of time to be able to both spin up and test. And so being that is something that's usually not seen as a planned for necessarily along the route, people on the bench have such great freedom and flexibility to be able to just produce to the requirements. This gotcha that comes up, I'm curious if you guys have a situation where you were facing challenges in the chosen contract manufacturers, both prescriptive means of being able to execute tests, limitations in their environments, or even some sort of limitations that their processes or manufacturing lines might have imposed upon you to be able to get your products out there that may have re-influenced the work that you've done on that bench?
I think that there's a couple of things that resonated for me, right? I think one of the big ones is definitely that when you're testing on the bench or you're building something on the bench, you're almost always assuming that the hardware under you works, and it works well enough that you're going to be able to develop software and ship that software. But like you said, when you're at manufacturing, you don't know if the hardware under you is going to work. So all of your software needs to be resilient enough to be able to handle, hey, this accelerometer is not giving me any values, or I can't seem to power on the Wi-Fi module or whatnot, and be able to bubble that up to the higher layers of software so that you can handle that. I think definitely have a lot of war stories from that, where some module has the software written for some module doesn't have that the right kind of assumptions that have been made, which tell you that whether that's going to work or not when you don't have faulty hardware, or you have hardware that is going to work some of the times. So that's definitely something I've seen a lot. And then, like you said, right, it depends on your flavor of CM that you're working with. You're going to have to worry about everything from what kind of software they have on the test station that's running or testing your device that's being built, to what version of it is it what kind of hooks do they need to the hardware from the software that you're going to be developing for them to be able to make sure that they test it correctly, and how do you react to things as they go through the production cycles, or even when they get to the field. So absolutely.
Shah, I'd love to be able to hear a little bit about the mechanical design that went into the robotics that you've worked with along the way, including some of the flagship robotics that you're working on now, in regards to contract manufacturer CM, sort of like moving into a mass manufacturable state. There's procedures and things you can do for plastics, like using injection molding techniques that can get you design ready for manufacturability, that you would sub in at some point during your journey for 3D printed designs, in which case themselves would have their own sort of imposed limitations. Like, for example, if you're using FDM printers versus like laser printers, FDMs are those old, like the ones that are like extrude, like weed whacker cord, for everyone, here paying attention here. And that effectively, like the manufacturing principle of that seems to affect the choices that you can make in your design. Like, can you tell us a little evolution there?
Sure. And one thing that's really interesting is it's been about 1 year since we started using a contract manufacturer. We're working with Plexus. Prior to that, we built all of our own robots in-house, every single one of them. And so we've been around for around 10 years. So that kind of gives you a sense of how long. For 9 years, we built them ourselves. In regards to things like plastics, the very first robots, the scale was so small. We were building 1 to 5 robots. We would actually CNC them from a big block of plastic. It was very expensive, and we kind of knew that down the road that we would have to, come up with cheaper methods. But at the scale we were at, CNCing made sense. Eventually, then when we started getting into a dozen plus robots, then we switched over to vacuum casting instead for the plastics. And for vacuum casting, the mold can only last, I forget how many times, like 10 times before it has to be thrown away. And only, I would say, in the last year, when we started working with the CM, did we move to injection molding for the robots. So it depends upon where you are in the scale of your business. Compared to other IoT devices, like if you're thinking of like a consumer device, like a Fitbit or something, you're building, you probably need to get to those stages much earlier, than we did. But our robot was just, so expensive, to begin with, that early on in the process, that's why we took the approach of, doing CNCing and stuff.
I imagine
in terms of Oh, sorry,
just to touch on that for a second, I imagine the flip side of that problem being, like, if you were to use different manufacturing techniques in those cases, like if you reached for less expensive rapid prototyping technologies, it would kind of require you to have to rethink the way that you'd mount those types of plastics or enclosures, which would inevitably be mechanical design features that would be wasteful and that would not be in service of the final design anyways. Is that sort of what part of the decision-making process that you took with the desire to go towards like CNC as a means of something that could be short-circuited at a higher manufacturability with something like at the vacuum mechanisms and then injection molding techniques some sorts?
Sorry, can you say that one more time? I didn't quite catch that.
Sure. I was just it has me thinking about if you were to be able to print out about a bunch of plastics to comprise your enclosures earlier on by using like a smaller manufacturability technique, it seems like it would require you to have to add more features to your mechanical design, like the frame of the robotics themselves, to allow you to adhere those plastics to it in components, versus making them in larger scale, which kind of requires you to have to lean into these more expensive techniques, but in service of producing the robot you want, and not one that kind of has the look of today, but has a more screws and a means of adhering the enclosures to it. Is that part of that trade-off maybe in that case, like to overcome the limitations of smaller prints? So you'd have to be you required larger rapid prototyping mechanisms early on.
Yeah, I mean the mechanical design is constantly changing. You know, even today, the product we have today is always evolving. So you know, we design things mechanically for the stage that we were at. I can't speak to it in more detail because I'm not part of the mechanical team who designed the robot. So I'm trying to go off of memory of what I do know about the robot.
What are the volumes where you really have to start thinking about getting through scale here? So I like what you shared about the team did everything by hand for a good amount of time, and that is no longer scalable. You're working with a manufacturer, but at what point do you really have to, is it like getting to 100 devices, getting to 1,000 devices? Like when are you starting to really think about manufacturing process optimization and bringing in, and this might be a little bit on the topic as well, but just how do folks think through this?
So, you know, for us, we started, you know, when we started getting into, several hundred robots, that was sort of where we had to switch over to a CM. Because of the demand for the robots, we needed to manufacture them at a sufficient rate that we just internally, you know, could not do with our own team. And it's just not only just team size, it's just having space for all the, you know, all the components, managing supply chain and everything. The CM handles all of that for you. So that's kind of when we made the switch over.
Yeah, and then
sorry. Go ahead,
in my experience, I mean, it depends, right? I think for me, it's been a mixture of things, right? If your end product, like at Apple, you know, with their consumer products, they build a few 100 million of them. So that phase that you talked about comes a lot earlier in the production cycle, right? They do stuff with 3D printed material, and that's generally even before you put electronics in them, because you want to go see how, you know, the form factor is going to feel in your hand. You're going to do a bunch of tests through that form factor as well. And then as you get and you build your first electronics inside the product, they're already doing, you know, a few hundred of them already at that point, the first time that they make a phone or a watch or an iPad or whatnot. So obviously it depends on the manufacturing scale that you're going to hit towards the tail end as well. That'll drive how soon you want to, you know, lock down your mechanical or electronics or manufacturability of the product as well, right? So where so more I think low volume will mean that you can go and absorb that later into the production side or closer to, you know, going to production and shipping to customers, than if you are someone like an Apple or even Tesla for that matter, with the kinds of volumes that they hit on their products today.
So I think this is a really good.
I was curious about one more thing on this case too. I was curious about you've worked on some technology that has to operate in some pretty harsh conditions, and it just had me thinking about the path towards production and how when like companies like Apple or larger scale ones who are going to be going into a very large mass manufacturing mode do that a lot earlier in the cycle. Where do you see a lot of like the testability come into play or start to be able to be exercised for things like predicting or preventing future regression? And I'm kind of pointing a bit at some of the ChargePoint work on the those devices having to exist in outside externalized conditions, weatherproofing, stuff like that. So
yeah. So actually, ChargePoint has a great video on YouTube about this as well, and I'll give you like maybe a 30-second to 60-second overview of that. I think every time you make hardware, right, it has to be for purpose. It has to be like every time you do a specific hardware build to evolve your product over time. And one of the main things to do with that hardware build is always to go push that to a reliability team. And what the reliability team is going to do is they are going to try and push that device or the set of devices to a stage where they are going to compress the life of the product to see how quickly or when does it fail, so that you can take that feedback. And let's say that you're building a product like ChargePoint for that should survive in the field for, let's say, 10 plus years, and you start having part failures in 2 or 3 years, that's going to be a problem, obviously, right? So you're going to take that, you're going to figure out what the root cause of that was and feed that back into your design cycle so that the reliability of products as you go through hardware builds improves. So whether it be an Apple or ChargePoint or Tesla, everyone, I think reliability is one of the key product teams from a hardware and mechanical, and I mean less software, but definitely hardware and mechanical standpoint, so that you can feed that back. ChargePoint, for instance, they have an entire lab that does everything from wind testing to rain testing to different environments. I think our chargers are rated for -40 degrees Celsius, if I remember right, on the low side, and then up to, I think maybe 50 degrees Celsius, which is pretty hot. So that's a pretty wide range. And to get through that, you have to do a lot of testing within lab space. They have a shake table where they put a pretty large charger and then just shake it to see how shaking or vibrations affect a particular charger. And there's a bunch of things. And there's a YouTube video out there. So if you search for ChargePoint reliability, I'm sure you can find that as well.
Do you guys shake the robots, Shah? How much do you shake the?
I saw Shah smiling as well when I was talking.
We have kids do the shaking test at stores. They love to jump on it and shake it.
Sure.
Yeah. Teenagers love to knock them over. We get all sorts of stress testing every single day.
Yeah. Well, let's transition to the next topic. I think we've danced around this a little bit, but thinking through things that don't scale and when to invest. In the rehearsal or in our pregame, we talked a little bit about this on the digital front, but I think some of the conversation already has been on the physical engineering side and really getting ready for manufacturers. So who wants to kick us off? All right, Justin. Yeah, stop. Go ahead. Yeah.
Now, I mean, I don't know, how much can you not talk about this, right? It's what is important and what's not. I think let's pick up security, right? I think security is one of those things that obviously every product wants to be secure, right? But it's a really open-ended question in terms of how do you make that secure, and then when do you invest in either building a security team or doing the right things from a security perspective when you're building that product, right? And I think when we were chatting about this at some point as well, how like, do you think of architecture early on? Do you invest in that architecture early on? And I think one of the things that we've been talking about is, I think architecture makes sense to at least think about in the early stages of product development, because that might affect the hardware design. It might affect what components you might even pick. But maybe you don't invest in that, at the early prototype stages as you go build your product out. And then you might have a checklist which says, before we ship, we have to have, these things from a security standpoint. But that before you ship might be a road, 6 months, 9 months, or 12 months down the line, versus, when you're building your first prototype. So I think, yeah, that one's definitely close to heart. And it kind of goes into security. Security kind of goes into certificate management and how do you identify those devices, et cetera, right?
Yeah, I think it's fun. Security is a great one to riff on. I mean, it's yeah, there's the old adage of like, it's not binary, it's like a gradient, right? And like security, there's like how the people would think that a lock is secure until the fact that, well, locks have manufacturing tolerance issues and picking locks is a thing. And To that point, it's like there's situations where I've seen people who have doors that have like 6 or 7 locks on them, right? And then well, is that more secure than my door that has 1 lock on it? Well, it depends. Do you need 6 locks on your door to be able to feel secure, or do I need only 1 to feel secure in my case? And that's kind of a way to pin it back to the idea that it is a sort of product domain requirement driven, right? And like for example, and this one hurts a little bit too, because I know I'm familiar with a lot of the different ways you can secure things, and like to list a few, like encrypting the data that's on the disk at rest, encrypting it while it's in flight. Well, hopefully everybody's doing that, and having secured provisioned identities so that the device has a root of trust that is birthed in it. But just to pick on the first one a little bit, encryption at rest. Does everybody need to have encryption at rest? And now, the purist in me argues that, well, if it's available, then yeah, turn it on, right? But product requirements in those cases might not dictate that in all situations. And while there is added complexity in the case of that gradient of how secure you want to be, the more security features that you implement, the more complexity that's going to get involved. And so to pick on this one a little bit, like have you seen situations designing your products where the gradient made sense? And even through that lens further, where does it make sense in the service of scaling, and when to invest, to add those features?
I think I couldn't have. I think no one could have put it better, right? Do you need 6 locks on your door, or do you need 1, right? Kind of thing. So, but I'm curious. You mentioned that you mentioned device identity and root of trust. Can you elaborate on that a little bit more, Justin?
Sure. Yeah. In the case of a device's identity root of trust, the easiest way to be able to kind of pin this back is to say, like, well, for a long period of time, humans piloted computer workstations to be able to gain information, log into websites, search the internet. And the human, when needing to be able to be challenged on proving their identity, would type the password in, right? And that's a great challenge that we've lived with for a long period of time. Machines have these days become purpose-driven into the point where they are their own actors. They could be used by many humans, they could be used by individual ones, but regardless, they're autonomously in situations performing actions on their as if they're their own actor, their own human themselves, right? And so, how do you protect the password that a computer would need to be able to present when being challenged for the authenticity of its identity, similar to the human that would do that? And that complex problem kind of manifests as like, well, naively, let's just store it on disk and replay it. Well, there's various problems in that case. The credentials are in clear text. You could read them from the disk remotely as an attacker, or locally if you get into the system. And so a lot of techniques have come about using certificate management, which is public key infrastructure certificates, similar to the same ones we use to protect traffic going against the internet, SSL, that can be used to authenticate or be used as a challenge for the device to present itself as its identity securely. And one fun way that we do this these days is, well, once again, you can't just put a private key and a certificate on the disk, right? Well, there's been an entire slew of secure enclaves or hardware security modules that people have gone through great lengths to be able to protect these things. The private keys are derived within this chip. And a fun piece about this journey that I've discovered along the way is that there's a popular one of these hardware security modules from a company called Microchip. They sell one that's that stores EC keys and is used prevalently in the IoT industry. And the chips themselves have physical prevention on them to deter people from being able to like peek inside the chip by means that they will take a trace and they'll just have it meander like it's drawing a maze that you'd have to get out of on a top layer to hide what's going on underneath it. And so if you were to like melt or burn away the silicon, like the chip layers on the top, you'd actually damage the physical component prior to being able to learn or tap into any of the registers of it to be able to retrieve identity or private information from it. Just another one of those wild security gradient mechanisms that comes along the way. So
I'm curious, in these different scenarios, so robotics versus charging stations, like what are Shah, what are you trying to protect against? What are your primary concerns with these robots?
So a lot of the same concerns with the other applications we're talking about. You're always worried about somebody potentially, hacking into a robot and doing something malicious with it, trying to, run it into the wall. Of course, our cloud backend, which drives our entire application. We need to make sure that that's secure, that somebody doesn't hack in and delete all of our data or steal the data. So all of those same sort of concerns exist, and yeah, we use the same kind of methodologies and technologies that were just mentioned to lock down our systems. But yeah, basically what Justin was saying, it depends upon your risk profile at that time. So when we started out and we had like one robot in the middle of a store in Ohio in a small suburb, we're not worried about world-class hackers hacking into the robot. So we obviously had basic security set up, but we didn't have to have the level of security that we have today. So for whenever you're building your application, you kind of have to consider, what are the sort of the risks and what is sort of sufficient, at this moment in time. So we just talked about security. I think you also mentioned things like auto updates. So you don't need to have an auto updater system until you actually, really need one. But early on, when it was just myself as the only programmer, and we had 3 robots, it was a big pain to get our software onto these 3 robots. So I was like, I need some kind of auto update system. And my auto update system ended up being just Dropbox. I installed Dropbox onto each of the robots. And as I built code, it would be saved to my Dropbox and it would sync to all of the robots. And bang, you had auto updates.
And then they created their IoT product. The Dropbox now does IoT.
Oh, they do? I did not know that.
No, I'm kidding.
So
Yeah, no, I'm kidding. Yeah.
Oh, you got me there. But it was after we hired our first person, it immediately fell apart because now we had 2 people writing to the same Dropbox folder, and it was causing conflict with files and everything. So we had to build something a little bit more sophisticated. So everything is iterative, and you have to sort of use your best judgment, whether it's security or auto updates, moving from off-the-shelf hardware to building your own custom, PCBs and things like that. You have to, for every application, it's different, and it depends where you are in the life cycle of your company.
On off-the-shelf hardware for you guys, how much are you leveraging some of the edge NVIDIA AI stack, and how quick have recent advancements made that easier for you, or is it relevant at all?
Yeah, definitely. Edge is an extremely important part of our solution. So on board our robots, we have both an NVIDIA and Intel GPU. Both of them are running models. Early on, we used to do all of our processing in the cloud. We would just upload everything, and now we still do that, but we do a lot of pre-processing on board the robot by running our models directly on the GPUs. This saves us a lot of money in terms of compute. We're continuing to find ways where we can push things onto the edge because those cloud costs really eat up a lot of money.
Yeah, I think it's
Go ahead, sorry.
no, go ahead.
I just talked with somebody at one point who was on the Amazon Echo team, and they were talking about the cost savings that they had made from doing the like voice recognition on the edge, and it was
So
huge.
you went mute for me.
Am I around now?
Yeah, just missed that whole like after the Amazon Echo.
Yeah, so they took the machine learning from the cloud to the edge and saved tens of millions of dollars for Amazon, maybe more, because they were doing all of that audio processing in the cloud, and very, very cheap to do that on their edge products.
Yeah, I think, but what Shah said, right? I mean, you start again with your MVP. You're going to be like, hey, I'm going to do this on the cloud. I don't have to worry about things. I have 3 robots in these set of warehouses, or grocery stores. But then as you like scale your footprint in the field, it becomes more important from both a cost perspective and scalability of the company perspective, right? So I think we lost Shah. Oh, there, he's back. So yeah, it becomes more important as you scale the footprint in the field, right? So
what were some of the can you say what were some interesting processing that you were able to do on the edge with ChargePoint? I mean, those things are very, very custom hardware and fairly critical infrastructure.
yeah, so a lot of what we did for power management at site levels initially started out with cloud only, right? So it relied on the cellular connection being active or the Wi-Fi connection being active. And you make decisions about power management up in the cloud, and you tell the charger that, hey, you have to balance power because you have 5 10 kilowatt chargers, but your panel at the panel that's fed from only has up to 35 kilowatts, for example. So if you have more than 4 vehicles plugged in that are all pulling 10 kilowatts, then you have to balance that out. Obviously, some of that can be done on-prem or on edge in some sense, where you can have communication within the chargers, or you pick a leader within the charger and they make that decision for themselves. They're not overly complex algorithms. However, having your devices communicate to each other, the actual overhead comes from those kind of problems than it does from the actual algorithm that needs to do the compute for power management, for example. So that's one example. And then there's a few, there's a whole lot of others that you can think about. And for the longest time, I think ChargePoint's not a new company in any sense. It's been around for maybe a little over 15 years now. And yeah, for the longest time, just did all of power management in the cloud and then sent back instructions to the charger in terms of what they had to do.
I met with somebody.
I was on the point that you all are making on the case of when to be able to invest and starting out early and scalability problems. It's interesting because there's a sort of it feels like a crossover point in which I guess the unit cost or the actual bill of materials cost needs to be reined in a little bit, and talked about edge processing and how much money that could save by moving it from the cloud. But obviously, it makes sense to start out in the cloud early, or reaching for simple systems or a lot of maybe even open source packages, just because you can just probably follow a blog post or two and get something working to be able to get you to that next stage. But it's then eventually it becomes this critical point of cost complexity. I guess yeah, it's interesting to be able to tie that then towards that flip side, that iterative approach, where you start to be able to cross that chasm towards making a product that actually can sell for a certain amount, and the amount of money that has to go into that iteration cycle to reach that place. Just wonder, like, I guess the unicorn there would be having easy to use tools up front that have delightful migration strategies to less expensive mechanisms. It just feels like the machine learning example specifically, cloud computing inference is something that has matured quite a lot, and that A problem that we face a lot in our domain, it feels, is that, you know, when pushing down to these devices, they're very specialty compute platforms that have their own little nuanced way to be able to execute inference on the edge, especially for machine learning algorithms or even mathematics in that case, and that there's not a lot of good bridging tools that are out there yet to be able to help that transition. And so spend more money to be able to spend less money in a way.
Astav, did ChargePoint anticipate that change, even if they thought that it was going to be years down the road? You know, we'll start in the cloud, maybe it will shift to the edge eventually. Was that something that was actively anticipated? And if it was, did that anticipation lead to design decisions to make that eventual transition easier?
That's a great question, right? I think the short version of the answer is yes, it was anticipated, right? I think
Well,
there's
say
a
no more.
there's
Please,
a
please.
mixture of things as always that goes into that conversation of, hey, when do you invest, right? I think the easy part of the equation here was that compute power was easy to have because it's not a very heavy algorithm. But you know, from a design perspective, how do you make sure that chargers can talk to each other? Do you build a Wi-Fi mesh between the chargers? Do you have you know, physical Ethernet connectivity or some other physical bus that you use to share that information between chargers? So I think yes, it was in our mind to go make that happen, but a few things from technology and time to go build that kind of technology from a engineering perspective kind of led to the decision or the thing being done more recently than a lot earlier in the past, right? So I think Wi-Fi mesh is a great technology. Not all of the chargers are actually physically Ethernet connected. So could you leverage that? And obviously that became more easily accessible more recently than earlier. So yeah, I think it's a combination of things that probably led to that.
Yeah, the problem is harder than some others too, because I think that the expected field life of a device is a huge variable there as well, right?
Absolutely.
You said 10 years, you know, well, that's a lot of time for a maybe to become a we need to, right?
Absolutely.
Yeah.
And I mean, technology evolves very, very quickly these days. So Wi-Fi mesh with a device that's even maybe 5 years old may not be possible actually. So yeah.
Well, and with the EV charging stations, I mean, in a Wi-Fi mesh, you have like Faraday cages running around on wheels in between all these devices, and I think connectivity is probably a
Or the
nightmare
amount of
at
time
times. Yeah.
the amount of time we spent in connectivity. Oh my God, yeah.
Awesome. Well, let's kick over to the last topic. So, been a lot of fun. I think we both, not both, this panel all has different sizes of teams that they're optimizing for, but would love to just hear some freeform thoughts on building cross-functional teams for hardware products. So, Astav, why don't you kick us off?
Sure. So I think for me, my background or my career has always been in organizations where they've been matrix organizations. So they've basically been cross-functional teams that roll up into a head of hardware or mechanical or software kind of thing, and software being both cloud and embedded separately more often than not. And then matrixing across to actually go build the product or set of products that company is going to build. Yeah, it's an interesting difference between, you know, building a GM kind of organization where there's a general manager managing, let's say, the iPhone versus the iPod versus the iPad or whatnot. But at least my career has been always matrix organizations across where, let's say, the embedded organization or software organization or cloud organization, they can always do the best across devices, right? They can make sure that if there's some feature that you know, we need to do from a security standpoint or from an auto update standpoint, you can do it once and you can apply it to more than one device over time. So yeah.
So, say you're going to develop a new product at ChargePoint, and how many people do you pull together for that?
So let's say that you're building the next, I don't know, home charger, right? You're gonna probably start with a mixture of an industrial designer, a mechanical designer, double E, and maybe an embedded software person, and then come together and start brainstorming around how and what kind of feature sets would you want. Obviously, there's product. How would I forget product along with the engineering team? And you're going to figure out, okay, what kind of feature sets do you want? What kind of form factors would be applicable to those feature sets? And then as you go through that first iteration, then you're going to keep adding more people over time as you lock down, okay, this is 90% of what our product is going to look like. Let's figure out what that prototyping stages are going to look like from a hardware development standpoint. Let's build schedules into the picture. And then as you start doing that, you start putting in more and more of these matrix teams. You get buy-off from each of the teams in terms of do they have the right size of teams to be able to continue to support existing products and then be able to build these new products, and what kind of software timelines are we looking at, what kind of you find your manufacturing partner, et cetera, et cetera.
Cool. And Shah, the other side of the spectrum, we talked a couple of weeks ago. You're starting with a group of 3, and you're like, these guys are the jam. We can do anything. So, what do you think?
Yeah, it's you sort of hire as needed, of course. So when you find you've reached the limits of what you can do on your own, then you bring in people smarter than yourself. We didn't have an electrical engineer when we started. We were just piecing together off-the-shelf hardware with Arduinos and Raspberry Pis and duct tape. And so an electrical engineer was one of our first hires. I'd mentioned, computer vision was an area I was weak in. So, one of our earliest hires was in computer vision. One of the things I did not mention was we didn't necessarily go with the approach of hiring full-time people, but rather contracting in some cases. So, for example, with building PCBs, we contracted a company here in Silicon Valley that helps out specifically robotics companies rapidly build electronics. So everything, they were able to take all of our Arduino Raspberry Pi mess and build a PCB for us very quickly because they sort of had an expertise in that area, working with things like motor controllers and IMUs and whatnot. So that was a smart move for us because those guys have way more resources than if we just hired one electrical engineer, and we needed to move really, really quickly. Eventually, though, we of course took all of that over ourselves once we were able to hire our own engineers in that area. But it's a good strategy early on, potentially, depending on your application, to potentially go with specialized contractors for areas you're weak in.
Was there any challenges in transferring that, like not like legally, I'm sure, but like just the ownership mindset of that part of the stack from the contractor into your org? What was that like?
Totally. So yeah, we obviously we owned everything. We owned all the schematics, all the firmware, and everything. But of course, you lose a lot of like that institutional knowledge that you gain when you own everything yourself. So they were getting all of like those like insights, and we're not getting any of that. So I would say that was probably like the biggest loss. As we brought on people who knew what they were doing, it wasn't too hard for them to sort of figure out everything that was going on. The contractor we work with, they sort of have a model where, they, sort of hold your hand until you're ready, and then eventually they hand it off, and they're still available in the future, for a charge, of course. If you need help with anything.
Very cool.
There's an interesting parallel between contractors and a matrix organization. Yeah. A benefit being that you can pull the expertise as needed, and it's cost efficient, as opposed to hiring a full-time person up front for every single thing. Yeah, it's really interesting. You can attack that in a couple of different ways. We just saw, two different approaches, but solving the same problem. You want to pull in that expertise early. Well, why? Why did you bring in an EE and a machine learning person up front? Why didn't you bring in, a painter? The thing's gonna have a coat of paint when we ship it. Why isn't that, why didn't we bring that in up front? Well, some companies do, if that is truly important, if it's meaningfully gonna impact things. But in this case, you bring in the right people at the right time for the right amount of time. And then even more interestingly, eventually that cost becomes worth it, where you're like, no, I do want to invest full time. I do want to be, collecting these insights so that we can get that efficiency. And we won't get that if we always dip into a contract or something like that.
Yeah. I'd also add, when we make the decision of going between a contractor and full-time hire, it's based on what actually has value to your product and makes you unique. What's if if it's something to do with your IP, you kind of want to bring on full-time people for we didn't worry that much when we were doing things with PCBs, because somebody interfacing to a motor controller or an LED, that's not anything special. We don't really have like IP around that. So yeah, when hiring, you want to kind of keep that in mind. If it's a core part of like the bread and butter of your business, you kind of want to own it in-house.
All right. Well, I think we are at the top of the hour. So I see a couple folks have dropped, but this is a really, really great time. Thank you all for participating in the panel and everybody who joined. And stay tuned. We'll be doing a few more of these throughout the summer, and heavy emphasis on AI applications on the edge. So thanks again, and we'll see you on the internet.